Next, we need to remind ourselves of the meanings of reduction and oxidation. This atom here is oxidized. It loses. Ox means loss of electrons. So there comes away the electron. It's lost from this chap, meaning that this one is oxidized. This one here, he receives that electron. He is reduced. Reduced means it gains electrons. Now, you can never have a substance being oxidized unless another one is prepared to take the electron. In other words, another one is reduced. You can never get a substance to be reduced unless something else is prepared to give it an electron. In other words, something else is oxidized. The two always go together. Now, the one that is oxidized, by it being prepared to give an electron to the other, it reduces the other. So it is a reducing agent. The one that takes the electron, he allows the other one to be oxidized, and so he is the oxidizing agent. So the one that's oxidized is the reducing agent. The one that's reduced is the oxidizing agent. Can you remember how to answer a question like this? You are given a chemical reaction. Copper chloride solution is electrolyzed, meaning a current passes through it, and that changes it into copper solid and chlorine gas. And what you are asked to do is give the oxidation number for each of the atoms involved here, and then show the changes in oxidation number. Now, perhaps you remember from grade 11 that an increase in oxidation number is another way of defining oxidation. Just now we defined oxidation as the loss of electrons. Now, whenever electrons are lost, oxidation number will increase. So those are two synonymous ways of defining oxidation. Reduction is a decrease in oxidation number. We've just seen it means a gain of electrons, and whenever electrons are gained, oxidation number will be reduced. And then you need to identify the oxidizing and reducing agents. Now, in order to do this, you need to remind yourself of what oxidation number is. It refers to the number of electrons shifted towards or away from that substance. If the electrons are shifted towards that substance, then the oxidation number is negative. And if the electrons are shifted away, then the oxidation number is positive. And then we refer to how many electrons are shifted this way in the oxidation number. Now, another thing you must just remind yourself of, which I've just referred to actually, is that copper chloride doesn't contain copper atoms and chlorine molecules. It's very easy to think that that Cl2 in there means Cl2, the green gas. No, it does not. That is not what this means. No, this here is an ionic substance which is in solution. And what does it mean if something's in solution? An ionic substance is in solution? It means that the ions are hydrated. The ions are separated from one another and surrounded by water. And so here we don't have copper and chlorine. We have copper ions, and because it's dissolved, they are surrounded by water. We have chloride ions, and because it's dissolved, that's surrounded by water in either solid or aqueous phase. This 2 simply means the ratio of how many copper ions to chloride ions there are inside the substance. Now, pause the video until you've answered each of these questions here. Here we have the oxidation numbers. The copper ion has an oxidation number of +2. Why? Because 2 electrons have been shifted away from it. Now notice that the charge on the ion is 2+. The oxidation number is +2. The magnitude is the same, 2. And also the sign, plus, is the same. The difference is just that in oxidation number, to distinguish it from ionic charge, we write the sign, plus in this case, first, and then the number. Whereas with ionic charge, we write the number of electrons removed or gained, in this case removed, and then the sign, plus, just to distinguish the two. Chloride, remember this is not chlorine, it's 2 chloride ions for every 1 copper ion, has an oxidation number of -1. And again, the charge is 1-, the oxidation number -1, because 1 electron gets shifted towards each chlorine. Notice that each chloride ion has an oxidation number of -1, but there are 2 of them for every 1 copper ion, so that's why the substance as a whole has an entire oxidation number of 0. 0, or we could say is neutral overall, because this -1 is actually multiplied by 2 to see what the overall effect of the chlorides are. Now, what about after the reaction? We're left with copper atoms. Now, copper atoms don't have any electrons shifted either towards them or away from them. They're neutral and they're not bonded to anything else, and so the oxidation number is 0. And what about chlorine molecules? Now, chlorine molecule is a covalently bonded molecule between two chlorine atoms. And these two chlorine atoms, we could also represent this with Lewis dot notation. They each are halogens. They have a noble gas configuration, and each of them has 7 valence electrons. And they share their 7th valence electron with one another, in that way feeling as if they each have a noble gas configuration, because it's as if there are 8 valence electrons orbiting each. So here we have a covalent bond, and these are the shared electrons. Here in Cooper notation, we just draw that as 1 dash, the 2 shared electrons. Now those electrons are shared perfectly equally between the 2 chlorine atoms, because the electronegativity difference between chlorine and chlorine is obviously 0. Each atom, chlorine and chlorine, is just as greedy as the other. And so since the electrons are not shifted anyway, we can see that the oxidation number of chlorine in this form is 0. So which chemical has been oxidized and which one's been reduced? Remember, oxidation is a rise in oxidation number, and it's because of loss of electrons. Reduction is a drop in oxidation number because of a gain of electrons. And we can see that the copper ions are reduced to copper atoms. The oxidation number changes from +2 for the copper ions to 0 for the copper atoms. That's a drop in oxidation number, and so it's reduction. How could that have happened? Well, copper ions must have gained electrons, actually 2 electrons for each copper ion, to change it into a copper atom. Where did it get those electrons from? It must have got them from the chloride ions. We see that the chloride ions, their oxidation number changes from -1 to 0, which is a rise in oxidation number. And that happened because of a loss of electrons. These electrons were lost by chloride, given to the copper ions, and that changed the copper ions into copper atoms. It reduced the copper ions to copper atoms, and it changed the chloride ions to chlorine atoms. Remember, this Cl2 and that Cl2 are not the same thing. This Cl2 is actually 2 chloride ions for every 1 copper ion, whereas that here is the actual Cl2 molecule. Now we write the oxidation half reaction for this reaction. 2 chloride minus aqueous changes into Cl2 gas with the release of 2 electrons. And the reduction half reaction. Copper 2 plus ions in the aqueous solution gain the electrons given off by chlorine to form copper solid. The entire redox reaction is these 2 half reactions combined. So everything that was on the left hand side of the arrow, we now write on the left, and everything on the right on the right. And so we have copper 2 plus aqueous plus 2 electrons plus 2 chloride ions react to form copper solid plus chlorine gas plus 2 electrons. But here we have a repetition of electrons on both sides of the equation, so we can simplify the equation by removing them, since an equation is meant to show change, and since as many electrons are gained as lost, that doesn't involve a net change in the amount of electrons present. And so we simplify this reaction to Cu2 plus aqueous, copper ions that are dissolved, in other words, plus 2 Cl minus aqueous, chloride ions that are dissolved, the 2 meaning there are twice as many chloride ions dissolved than there are copper ions dissolved, gives us copper solid and chlorine gas. And then we can join those 2 in the form CuCl2 aqueous, although that is misleading, as I've explained before, because it tends to make us think that there are copper atoms, whereas there are not. There are copper ions in there, and it makes us think there's chlorine molecules, Cl2, whereas there aren't. There are chloride ions, and that 2 just means double as many chloride ions as copper. So it's not really a very good form of writing this. Also, the copper ions and the chloride ions are dissociated. They're apart from one another, each surrounded by water, and so it isn't really right to associate them with one another since they aren't bonded with one another. But since it's a shorter form of writing it, we do use it, and so that is what we call the formula equation, whereas the one just above it is what we call the net ionic, because it's the overall ionic equation, and then this one here is perhaps the ionic, not net ionic. Now all that remains to be done is to determine the reducing and oxidizing agents. Remember, the reducing agent is itself oxidized. The oxidizing agent is itself reduced, and we saw that it was the copper ions that were reduced to copper atoms. So the copper ions are the oxidizing agent because they make the other thing, the chloride, to be oxidized to chlorine. The chloride being oxidized is the reducing agent, since it is what reduces the other one. It reduces copper ions to copper atoms. As I've already reminded you, the meaning of oxidation number is the number of electrons which are either lost or shifted away, or gained or shifted towards that particular atom for one atom of that element when it formed that bond. And if some electrons were either lost or shifted away, then the oxidation number is positive. If some were shifted towards or gained, then the oxidation number is negative. Now for an ionic substance this is very easy because it simply is the charge of the ion. But if it's a covalent bond and we're looking at the two atoms involved in the covalent bond, for each of the atoms we look at, are electrons shifted towards that atom because it has a higher electronegativity than the other one it's bonded to, or are electrons shifted away because the other one has a higher electronegativity.